Thanks, people. This is day one of school from home, and I'm here with one of my cats who is choosing to be an assistant physics teacher for today. Okay, for today, we're looking at your packet. The first page in your packet is just some notes about kinetic energy and potential energy. And then, if I've done this correctly, I think this is the second page in your packet. If not, you can turn through until you see this. So we've talked about potential energy and kinetic energy before, and today we're going to start discussing how to calculate those. So our formula is right here. Potential energy due to gravity is mass times gravity times height. And they have a few sample problems for you right here, so I thought we could work through those. Give me a quick second to put my phone in the holder. Okay, hopefully I'm still in the frame now. Okay, so we're going to do this first problem right here. And potential energy due to gravity, the formula is mass times gravity times height. And we're going to go through and identify our variables. We're doing this one right here. Our mass is 10 kilograms. Gravity, you guys already know that. That's 9.8 meters per second squared. And our height in the problem is 5 meters. So we substitute our variables into the problem just like we've done before. 10 times 9.8 times 5, and that is going to equal 10 times 10 times 9.8 times 5, and our answer is 490 joules, and this is potential energy. Okay? Well, this is from something that's up high in the air. It's 5 meters in the air. So if it starts to fall, you guys know that that potential energy is being turned into kinetic energy. It's falling, it's starting to move. Right at the moment where it hits the ground, it has no potential energy because its height is 0. So it started up here, 5 meters in the air, and now this box has fallen until it is 0 meters. It has no height. And all of that potential energy has turned to kinetic energy. So all 490 joules of potential energy has been transformed into 490 joules of kinetic energy. So as a thing falls, it starts out with this much potential energy and no kinetic because it's not moving. And as it starts to fall, the potential energy is being turned into kinetic energy until eventually we end up with 0 potential and everything has become kinetic. That's going to help you in some of the problems on the back. I want to go to the back, and in the past I've had students who have been confused by a few of these problems. So I want to try and help you out because some of them are poorly written. So if you guys look right here, circle the one with more kinetic energy. This problem should say a 25 kilogram mass or a 30 kilogram mass, both moving at 5 meters per second. It doesn't have that word both in there, so a lot of my students thought the 30 kilogram mass was moving, but they didn't know that the 25 kilogram mass was moving. So in this particular problem, you're going to circle the one with more kinetic energy. A 25 kilogram mass that is moving at 5 meters per second, or a 30 kilogram mass that is also moving at the same speed of 5 meters per second. You're going to circle the one with more kinetic energy. If we come over here to potential energy, there's another problem that's confusing. There is a 25 kilogram mass or a 30 kilogram mass. And again, they left out that word both at the top of the hill. So you're going to circle the one that has more potential energy. I think a lot of the rest of the page is should be pretty doable to you guys. You just need to calculate potential energy like I just showed you. Potential energy, you're going to do that. When you come to this one, a 25 Newton object is 3 meters up. Gravitational potential energy is equal times mass times gravity times height, which is a distance. Well, mass times distance can be, mass times gravity is a force. So gravitational potential energy can also be written as force times height. And if you look at that problem, look at the units of the problem, one of those units is a force, and you should be able to do that. Okay, over here on this side, we start seeing kinetic energy problems. So let's take a look at some of those. I'll leave that up there for right now. The formula for kinetic energy is 1/2 times mass times velocity squared. And just like it says in the note page on the front of your packet, only the velocity is squared. You're not squaring everything in the problem. So I'm going to go back to the front page, and down on the bottom of the front page they gave you some problems here. So we have an object moving at 20 that has a mass of 20 kilograms moving at a velocity of 10 meters per second. Let's calculate that kinetic energy. So in that case, our mass is 20 kilograms and our velocity is 10 meters per second. So we're going to substitute those numbers into our formula. Kinetic energy equals 1/2 times 20 times velocity 10, and only that 10 is squared. And so when we put that into our calculator, okay, 1/2 times 20 times 10 squared, and you should get 1,000, and again the unit for energy is always joules. So that's how you calculate the kinetic energy of something. When you come over here and start doing the back of this worksheet, kinetic energy, kinetic energy. This one, a rolling ball, has 18 joules of energy and is rolling at 3 meters per second. You need to find the mass. I'm not certain I gave that formula to you on your worksheet, so let me go ahead and figure that out. Let me see if I can find a different color. Don't know if that helps or not. Kinetic energy equals 1/2 mass velocity squared. We want mass. I'm going to multiply both sides by 2, so 2 times kinetic energy equals mass times velocity squared. I'm going to divide both sides by velocity squared, and that gives me mass. So in order to find the mass, it's going to be 2 times your kinetic energy divided by velocity squared, and that should be how you find your mass. How fast is it flying? Let me see if we can get that formula for you guys. So again, kinetic energy equals 1/2 mass velocity squared. We want to solve for velocity. That's going to be 2 times kinetic energy divided by mass, and we need to take the square root of the whole thing to get velocity. I am going to put the solving for mass problem formula back up there for you guys. Okay, that was 2 times kinetic energy divided by velocity squared equals mass. That should be every formula that you guys need in order to solve this back part of that page. You also have another page of kinetic energy or potential energy problems, but I'll go over that in a different video. Good luck, guys. If you have any problems, ask me on Remind. Thanks.